Welcome to the Digital Amateur Television Experimenters Night. This is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. You realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world. Also participate in the night by coming up to the Queen's Domain clubrooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7 OTC.
Okay, this is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania with our DATV Experimenters Nights, and I've got Rex, VK7MO, in the studio. Hello, Rex.
Hi, Justin.
How you going?
Pretty good, yes.
Now, I have to say, we've probably got some confused people because we've changed the name of tonight. The committee decided that we would no longer call it the DATV Experimenters Night, but we would call it the Wednesday Experimenters Night. So there's a little bit of a story with this because the Wednesday afternoon group, which you come up to, I think, yes, the Wednesday afternoon group is called the WAGs.
Yes. or geriatrics.
Oh, well, I prefer WAGs.
Yeah.
WAGs. And then the Wednesday Experimenters Night is the WEGs. The WAGs and the WEGs.
Right. Wednesday Experimenters Group. Right.
The Wednesday Experimenters Group. So, and we think that might appeal to a broader audience, but anyway, we'll see how that actually goes. I'm just trying to get it up on the screen because I'm not actually seeing it right at the moment. I might just try and do a refresh here and see. So the very first thing I wanted to go into tonight was just remind everybody that tomorrow, the 18th of April. Tomorrow, the 18th of April, is actually the World Amateur Radio Day. So, yes. Oh, yes, sorry. Okay, before we go into that, I need... Thank you, Rex. Yeah, I should be well following the script, shouldn't I? I should well and truly be following the script. Let me just click on here and the live stream and I just want to make sure that we're actually going out. And go, yes. Okay. Well, that looks a bit better. So, okay, let me start with acknowledgement of country. I wish to acknowledge Tasmanian Aboriginal people as the traditional owners of the land upon which we're presenting tonight and pay my respects to elders past, present and emerging, for they hold the memories, the knowledge, the culture and hopes of Aboriginal Tasmania. So thank you, Rex. Now, tomorrow, 18th of April, is World Amateur Radio Day. So what is World Amateur Radio Day all about? Back in 1924, there was a Well, the equivalent of the World Radio Conference today, back in 1924, but of course the UN didn't exist back in 1924.
No.
So there was a gathering of many, many nations. I don't know whether it was the League of Nations or whatever they called it before, but there was a gathering of nations in 1924 in preparation for a big international amateur world radio conference, I suppose you'd call it, in Paris in 1925. And so in 1925, the International Amateur Radio Union was formed. So it's about to have its centenary, actually. And so the theme of World Amateur Radio Day is a century of connections, celebrating 100 years of amateur radio innovation, community and advocacy. So that's the theme for World Amateur Radio Day tomorrow. And the reason it's on April 18 is that's the actual day back in 1924 that the International Amateur Radio Union was formed. They got together in preparation for Paris. So yeah, it's a bit of a momentous 100 years celebration of the International Amateur Radio Union. It's split up into 3 regions. Now my understanding is they're about to probably amalgamate a couple of those regions. So they're not, they're seriously considering there not being 3 regions anymore. But at this point in time, there are 3 regions, of which we're part of Region 3, which is that wonderful term which not very many people use anymore, but Oceania.
Oh no, it includes all up to Japan.
No, but including Oceania,
yes.
which is sort of Asia and us and a few other things, which Japan, all the way up to Japan, and all of the Pacific Islands, all of Asia, around Indonesia, Malaysia, Philippines, etc., etc. So,
is China part of Region 3?
yes, yeah, well and truly, and China, which is the huge part in the middle of that Asian area. So yeah. So tomorrow, what can you do tomorrow? Well, get on air is probably the key thing. Get on air and operate and celebrate a centenary of the International Amateur Radio Union. So that's what it's all about. And it's quite interesting. After 1925, the IRU history has noted amateur radio pioneers met in Paris in 1925 and created the IRU to support amateur radio worldwide. Just 2 years later, at the International Radio Telegraph Conference, amateur radio gained the allocations still recognised today, which is 160, 80, 40, 20 and 10 metres. So I think it was inspirational to... back in those days, we're talking 1925, so there's technology has moved on quite a bit since 1925, but to actually allocate amateur radio these bands in relation to if there is as harmonics,
yes,
then you're actually, those harmonics would be in other amateur radio bands, which I think that's quite inspired.
Well, they were quite important later on once crystals became available.
Yep.
Because you could just double and use the same crystal
on multiple amateur radio bands. I love it. I absolutely love it. So there was a bit of a technology driver there.
Probably, yeah.
Yeah. Okay.
I'm not sure the early amateur radio was crystal locked.
Right.
But not in 1924, but certainly in the 1930s.
Later on, when they started valves and they needed stability.
Then the amateur radio was certainly, because I remember my dad saying, "Oh, you've lost all the skills. People don't know how to grind their own crystals anymore." I
love it. get out the toothpaste, you undo the crystal holder, you take the crystal out, you grind it.
Oh no, that he was talking about. You went to the op shop, you knew how to find a pair of glasses that were made of crystals rather than glass, and then you ground them.
You cut and ground. Oh my goodness. Yeah. Okay. Right. Dear, oh dear. No, that's yeah.
And then you made your own holder for it.
Yeah, you made your own holder. Well and truly. None of this newfangled new crystal holder stuff.
Frequency synthesized.
E43 crystal holders. Oh my goodness. No, none of that. Oh, I love it. And hello to Lionel and David and Andrew who are watching, and thank you for finding us on the YouTube streaming channel. Now, what I have for you is the reason Rex is in the studio is Rex has a bit of a presentation for us, and I'll just get this up on the screen and do a transition. Okay, now Rex, what have you got for us?
Well, this is two very short presentations, and we'll do the first one because most people will remember that about a week and a half ago, or maybe 2 weeks ago, there was an eclipse across the USA. Now, if we just go to the next slide, the path of the total eclipse goes right across here, but
from Canada?
Well, it actually started down at there.
Okay.
And
so Mexico?
Yes, and went up to
Newfoundland.
Yeah.
This is okay. Big swathe.
But people a fair way either side saw partial eclipses, and they're plotted from sort of 10%.
So that's percentage. Okay.
Yes.
Oh, there you go.
Now, the interesting thing is a few amateurs tried to monitor what happened to the sun noise as it went behind the moon. And the only stations that I'm aware of that did this were both in San Diego. Can you point out San Diego?
San Diego. Oh, hang on. No, sorry. Let's go back here. San Diego's up here.
No, just above the border there.
Just there.
Yes. So they probably at the best had 50% or
55%. Yeah.
55%.
Yeah.
But that was sufficient to see the sun noise start to be obstructed. And if we go on to the next one, this guy is KB2SA, and he was on 23 centimeters with a 2.4 meter dish.
Okay.
And you can see he plotted the amount of sun noise.
About 55%.
Yes, at max of it, yes.
Yeah.
And it went from about, well, I think he probably didn't quite get the start, but it went to 6.5 dB down to about a bit over 4.5 dB.
Yeah, okay.
So even though much of the sun was not covered, he saw a 2 dB variation.
Significant.
And he was able to also take photographs, presumably with some sort of telescope and sun filter, of the eclipse.
Great.
And relate it. And I thought that was a pretty good bit of work.
Yeah, okay.
Now, another guy in San Diego who's a friend of mine.
Next one.
He had a go at it. And you can see it was probably, we can't really read the meters.
Hang on.
I think that's about 0.8 dB there.
0.8. Yeah, no, that's right. Decibels. And it's 1 point something and 0.8. No, it'd be 1.0.
The whole scale is 0 to 1. So,
so that's 0.8.
And this is down to 0.2.
Yes.
When more of the sun
Yeah.
was being covered.
Okay.
So, while it's not quite as spectacular, it was another measurement of
Well and truly.
it.
And that's at 3 centimetres, so even
That's at 3
so
centimetres
10
with a
10 gigs.
1.8 metre dish.
Okay. Okay. So this is equivalent to Richard's.
Yes.
Richard's setup.
Yes.
Yeah.
That's exactly right.
Okay.
He only got a 0.6 dB variation, but he clearly didn't
Start at that's because that's probably what 20%, 10, 15%.
Yeah, and then
That's probably the 50. Where's he? Did you?
he's
say?
also in San Diego.
Oh,
so,
okay. So that'd be the 55%.
Yeah, so maybe just the way his camera looks at them, it doesn't quite show 55% covered, but yes.
Well, there you go. I love it.
So that's a very short presentation. We'll just move on to the next one, which is about GPSDO stability.
Right.
I've been playing around, sort of worrying a little bit about the stability of GPSDOs, particularly between Richard and myself at 10 gigs.
Okay.
Getting variations of 5 hertz at 10 gigs.
What should you be getting? Nothing. No, that's
No,
that
you
wouldn't
should.
be that.
Certainly, it wouldn't be nothing. But I have noticed, for instance, that when I work some stations, even on the moon, after correcting for Doppler, it's always within 1 or 2 hertz.
Okay. So 1 or 2 hertz at 10 gigs. So 1 to the 10 to the 6th.
No, 10 gigs is 10 to the 11th.
Oh, okay. Yes. Sorry.
10 to the 10th.
10 to the 10th.
Yes. 5 in 10 to the 10th.
Okay.
It's not many people who worry about it, but I just tend to worry about it. So
Okay,
I did a test with a little what I call a signal generator, but it's a ZLPLL which generates a weak signal.
Yep.
And I normally just put the antenna outside on my balcony on a piece of tin.
Okay.
And compared that with what I was getting from my normal GPS antenna, which I don't know whether you can point it out, but it is
that one there.
that way up on the roof, and
which is not obscured by anything.
no, and I was getting point plus or minus 0.3 of a hertz, which is sort of similar to the at 1296. This is
Okay.
It's sort of similar to 5 hertz
At 10.
at 10.
Okay.
And I thought it was caused by the fact that I was using an antenna like this, which is supposedly a very good quality antenna, compared to.
Let's hang on. There we go. So this is a GNSS antenna.
Yeah, and basically
A commercial
grade one, which is supposed to sort of have a pattern such that it doesn't pick up the satellites right on the horizon, so it's only working with the satellites that have got good signals.
So there's a big patch array antenna under there, I assume.
I'm not sure.
No, but yeah. And it's active, so you feed power down the coax to it?
Yes.
Yeah.
Yes,
Okay.
it is active. It's got its own preamp in it.
Yep.
And the other one I was using is this one, which
lots of people would have seen these.
yes.
These are little. They've got a magnet on the back. You stick them. In fact, I've got one of these on the van for APRS. So it just sits on the top of the roof.
I had that one actually on a tin bit of.
So that's the one that's here.
Yes. Well, now next slide will show us the sort of results I was getting. So the one I was using two separate GPSDOs,
Okay.
both of which were double oven and pretty high quality commercial
Yep.
ones.
Okay.
One was called a Firefly 2,
Yep.
and one was called a Fury.
Yep.
And you can see there is a fairly dramatic difference between that and that, which I originally thought, oh well, the high quality one works better.
Oh, so this is the high quality one that's on.
In the middle is just when I put both the radio and the SIGGEN on the same one, and that cancelled out all the errors.
Yeah, okay, righto.
And what that proves is that the radio is not drifting at all.
Correct.
Because it's phase locked.
Okay. So we're more looking at these excursions here.
Yes. And my initial conclusion was, oh well, that's because this is a better antenna. So I then, in the next slide, oh, by the way, the scale of this is plus or minus 1 hertz. So from here to here is 2 hertz.
So that whole scale is 2 hertz.
Yes. So we're talking about something moving around there a bit more than
excursions of that's an excursion of what, over a hertz.
Yes, and with the other antenna it was 0.1 and a bit hertz.
Yep. Okay.
Next slide. So then I put both antennas in the clear, and I couldn't really tell the difference.
So when you say in the clear,
up on the pole. In fact, if we go 2 slides back,
yeah. So
they're both on.
So that's that versus that.
That's right.
Okay.
And so I then concluded that the difference was not because of the GPS antennas, it was whether they were in the clear or not.
So that variation that we're looking at there potentially is it not seeing certain satellites and being able to then average across all of those to give you the stability.
Yes.
Right. Okay.
I think.
Okay. Well, sounds plausible.
Yeah.
Cool.
So I then assumed that the antennas were okay, but to sort of prove the point, go to the next slide.
Yeah. Ooh.
What I then did is I moved one antenna in closer so it was more blocked by the house.
Yep.
And left the other one up in the air. And you can see how dramatic the difference is.
Well, that's well over 1.5 hertz almost.
Yes, and there are periods when this is that whole scale's about 10 or 12 hours.
Sorry, that was me.
So
that's 10 or 12 hours. So that's a decent amount of time.
That's right.
That's about an hour.
That's about an hour, and you can see how it sort of bunches up, but produces different frequencies for a reasonable amount of time. And I'm pretty sure this all relates to.
It would be fascinating to look at the actual data to see how many satellites it was seeing.
It would, but I don't have the ability to do that.
Digging into all sorts of things.
Yes.
But, well, that's fascinating.
Yeah, so.
And we also have the issue of we're at a relatively low latitude, and so our angles are a whole lot worse with GPS satellites, I think. Is that the...
GPS satellites are not in a geostationary. They're in an orbit that goes all over the place.
That just keeps progressing.
Yes. So they're on an inclined orbit. So I wouldn't think that.
No, okay.
I wouldn't
think that would affect it.
No.
Surely. Okay. But this is fascinating.
Yeah.
What would cause for a good hour?
Yes.
Some issues.
Particularly as those satellites rotate
Yeah.
Well, I don't know what their rotation is, but
The
most
precession.
low orbit satellites, 100 minutes go.
Correct.
Yeah.
No, well and truly. Until
No,
you see them again a bit further over.
They might. GPS satellites might be a bit higher up, but
Okay.
so
Well.
I thought that was useful to pass on.
Okay.
And next slide, which is the GPSDO antennas need to be in the clear.
Yep.
To get the best performance.
Yep.
And type of antenna doesn't seem to make any difference, at least.
Well, there you go.
And this is a sort of a $20 antenna, and this is $110.
Yeah, a lot more.
Yes.
Correct. Well, there you go.
All right.
See, that was my, because I lashed out and bought an expensive one.
Thinking it was going to save you a lot of money. Yes.
Well, it's going to save me problems. Put it that way.
Yeah. Well, that's what confused me in the first place. I thought if I've paid a lot more money, this one's got to be better.
Well, and actually, can I just say, one of the other things is these. Actually, both these. They're both active antennas, so you need to supply them with 5 volts or 3.3 volts.
But most GPS DOs that you buy
5 volts.
have the 5 volts.
It's a 5 volts, yeah. So there's a bias T arrangement where you feed it down the coax. You feed the DC down the coax.
But you don't have to worry about that.
No.
Just plug it on.
Correct. It does all of that, and
does it at both ends.
At both ends.
Yeah.
So well, there you go. It just needs to be in the clear. GPS, GLONASS, BDO. So that does all of it. That does GPS and the Russian and the Chinese system.
If your GPSDO does all those systems.
Correct.
And
Correct.
both my GPSDOs go back 10 or 15 years, so
GPS. Yeah.
They might not have all
Oh, there
those
you go. There you go, Rex. It says operating voltage from 3.3 to 18 volts.
Right. Well, you don't have to. You can't make a mistake, can you?
Nice antenna, though.
Well, I specifically bought that for my differential GPS.
Oh, yes. Okay.
Thinking that it would be better, and I sort of at the time convinced myself it was, but I now don't think so.
Right. Okay. Now, hang on. We've got Neil, VK3BCU. Hello, Neil. Rex, was this purely GPS, US Constellation, or did it mix with the other ones? I think we've just answered that.
Yeah, I can't be absolutely sure, but I think it's purely GPS.
It's of an era when the others didn't actually exist.
I suspect so, yes.
Yes. Depending on the chipset setup, you can sometimes set receiver into a timing mode where they know the antenna's not moving, so they don't have to calculate speeds and keep timing lock.
Right.
Okay. Thank you, Andrew. Even when down to one satellite in view. So there you go. Thank you, Andrew. Excellent. Well, there you go.
All right.
Well, that's fascinating, Rex. There you go. I'll give you that, mate.
Thank you.
And yeah, well, it's good news that you don't have to lash out and buy a $120 antenna versus a $20 antenna. So there you go. You just need to make sure that it's not obscured by anything else.
Yes.
There you go. Fantastic. All right. Thank you, Rex.
I mean, I should say, for most hams, even in 1 hertz drift to 1296, they're not going to worry about. Correct. But at 10 gigs, that's getting on to 9 or 10 hertz, and 24 gigs, 25 hertz. So,
now, that's an excellent segue. Our June presentation night, so not our May, not the next one, but our June presentation night is actually, we have Dr. Jim Palfreyman coming back to give us the sequel. And the talk he gave us in 2012 was Pulsars, black holes and atomic time. he's now come back and he's going to give us a talk entitled Glitching Pulsars, the sequel we've all been waiting for. So I have no doubt that he'll go into some time-related things. Given we are talking, Jim is the one who let us know last time that he has the PMG talking clock in his possession.
Well.
and he has actually got the thing working. He's a bit of a time nut. I have no doubt he's probably on the Time Nuts mailing list. So yeah, I feel certain that there'll be some references to accurate time. So there you go. Good segue. All right. Thank you, Rex.
Okay.
Thank you very much. Now, don't forget to take your jumper as you walk out of the studio.
Thank you.
It's fairly warm in our studio because we have a fair bit of equipment pumping out quite a bit of heat. So we have a few other bits and pieces tonight. Thank you, Rex. We have a few other bits and pieces. What I can do here is if I go over to here. Now, there'll be a few people on the stream who buy things from a Australian company called Core Electronics. If you buy Arduino, Raspberry Pi, and other bits and pieces, then you will no doubt probably have purchased from Core Electronics. And they have a bit of a reputation where whenever they send something out, they send you a bunch of interesting stickers and other information sheets. And the last package that I got from them had this wonderful Resistor color code calculator. A whole lot of concentric circles. You put them together and you then read off from the outside for like, let's do 1, 4, 4, 4, and then orange. So if it's yellow, 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 orange, and then it will be something like brown. If it's an E96, I think E96, I think is the one with the most numbers, most number of bands on it. But what would that be? 444 K with a 1% tolerance. So you would read across the numbers. Now, the thing that I wanted to point out here is there is a wonderful, and I'll just zoom in here. There is a wonderful. This particular one, obviously, you need to put a pin through the middle. One of these pins, which I haven't seen in a very long time, but it just says here, no paper fastener, no problem. You twist together 2 resistors and then twist them together here, and you can make yourself a little paper fastener which you can put through the hole and then thread all through each of these holes until you get your resistance calculator all put together and able to be used. So I thought that is a wonderful bit of innovation for calculating resistor values. So there you go. Now I just wanted to do a little bit of a quick revisit of the end-fed half-wave. There's been some chatter on our Discord channel about end-fed half-waves and the fact that people are finding they're a bit hit and miss. They built one and didn't quite work, or had a lot of trouble tuning it, or had a lot of trouble getting it to give them low SWR, etc., etc. So I'll put a link in the video description to the video that Hayden and I did a long time ago, quite a few years ago, on Ben VK7BEN's end-fed half-wave kit, And thank you, Ben. Ben was here earlier, and I think he might have gone home. He might be on the stream, so if you are on the stream, give us a hoy, Ben. So this was Ben's kit that we put together, and then I did a fair bit of experimentation with this kit. So this particular box that has the unun in it, the unbalanced to unbalanced, has quite a few modifications to it that aren't actually in the kit. You can see, hang on, where's my pen? This is the 1:64 transformer, so unbalanced to unbalanced. I have put, normally there is a capacitor, a high voltage capacitor in here. Actually, let me zoom in here. I've put a broadcast capacitor in here, so this is out of a broadcast radio. I put a little insulated knob on it. And I've also, it came with a UHF. I put a BNC on there because most of my antennas are BNC. And I've also put some ends on here. And you'll notice this goes all the way through. I can put this on top of one of our squid poles, our fiberglass squid poles, and it goes through here and just sits on the top of the squid pole. And then this is where the antenna goes off. You can see the antenna wire here, and there's an insulator in there, and it goes off to a bit of Kevlar cord. So that's the antenna. On this end, this is the ground. This just goes to the ground side. And you'll notice that I've got a little bit of red wire here, which is, it's actually 0.05 of a wavelength at 40 meters. So it's not that long. It's only about a meter, probably 1.75 meters. So what's that? 6 feet of wire on there. That is the counterpoise. So a lot of the end-fed half-wave antennas actually they rely on your piece of coax that goes to your radio as the counterpoise. And so if you've got it in an arrangement where you've got an inverted V, and inverted V's in end-fed half waves are actually really good, because if you plot the voltage and the current on an end-fed half wave, and we do that, there's some plots that we put on the screen in the video that I'll post, you will notice that it's the current that radiates in an antenna, and the current peaks in the middle of an end-fed half wave. Because it's half a dipole, and so the current actually peaks in the middle, and if the middle of your end-fed half wave is on the top of a pole, and if I have a look, I may be able to, yeah, you'll notice that about halfway through there is a knot in here and a loop, and that loop is what I put over the top of the squid pole, the fiberglass squid pole, and so I can put this into a end-fed half wave. And what that means is the unun only needs a very short piece of coax to the radio. And the problem with having a very short piece of coax to the radio is, of course, you don't have any sort of counterpoise, because what it's relying on is at least 0.05 of a wavelength, and at 40 meters, which this is the lowest frequency that this is made for, is 40 meters, you need probably a bit more than your little short piece of coax. That's just not going to do you any favors with your end-fed half wave. So put at least a 0.05 wavelength counterpoise on it, and you'll find things will probably make a whole lot of difference. So I talked about the current's in the middle. Now, the problem with that is that means the voltage is highest at each end. So that's why you need high voltage capacitors for if you're running any sort of power. You do need high voltage capacitors. I only run this for QRP, so that's why I've got the broadcast capacitor in there and it doesn't flash over. So that's, yeah, but if I was running any more power, I'd be thinking about fixed resistors in there. The other thing with the end-fed half-wave is, and the reason why it's a 64:1 transformer is, if you plot out the resistance, the characteristic resistance of the antenna, it can be anything from 1800 to 5000 ohms, and to match to that is a bit of a challenge. You want to get down to your 50 ohms, so there's a 64:1 in there, and the capacitor just enables you to null out any sort of reactive elements. So that's the other. Very easy. The video on the video I'll post. It goes through a tuning, how you tune an end-fed half-wave antenna, which is really easy. You have like a 3.3k or a 4.7k ohm resistor. You connect your counterpoise if you've got one, or your coax if it's long enough. You put a resistive load where the antenna is with your resistor, and you then match. And in my case, I can then turn the capacitor to match it so that there is you get the best match. So the resistive hopefully you get back to and able to match to the where there is no reactance. It's purely resistive, and you can then get it down to that 50 ohms that you're looking for to match. Then what you do is remove the resistor and put your antenna back in place, and if you get the same result, then your wire is probably about right length. If you need to put some more capacitance, some more C in there just to get it to match with the wire, then your wire's a bit too long, and if you have the reverse and you need to remove a little bit of C in there, then your wire's a bit too short. So it's a bit of a great little tuning arrangement just to get the wire length optimal for your particular setup. So yeah. Anyway, I'll post all of the references, but that's the end-fed half-wave. You can use it in a long wire configuration, or you can use it as a inverted V configuration. I personally like the inverted V configuration a bit more. I used that a little while ago when I was making sure that this all still worked, and made a 20 meter contact to France on 5 watts. So I took that as being that the particular antenna is working pretty well. I think his signal report was like 4 and 1, and I gave him about a 5 and 5. He was running 500 watts and I was running 5. So so the antenna certainly works reasonably well. How are we going for time? Okay, got 15 minutes. Excellent. Now I'm going to do a blast from the past segment. I happen to be delving into some drawers at my workplace, and somebody was cleaning out some drawers, and they said, "Oh, what's all this old crappy equipment that we've got in here that we need to get rid of?" And I took one look at it and I went, "Well, you can throw it my way, because I know what that crappy equipment is all about." So, for those who remember RS-232, the serial standard RS-232, this is serial communication standard, and in fact your USB still uses serial communication in a very similar fashion to RS-232, although they have pushed the limits on speed of RS-232. Now, lots of people will know the Black Box Company. The Black Box Company, I think, still exists. I'm not quite sure. It's probably gone to much more sophisticated equipment. But there are, I'll put it up here and show people. So this is a Black Box serial RS-232 experimenter's kit, I suppose you'd call. There is a dual sex, so there's a male and a female on each end. So you can match to whatever you're connecting to. It's a DB25, so it is a full 25 signals RS-232. There is another standard which is a DB9, which breaks down a lot of the other. It breaks it down to the minimum number of control signals. This one has a bit of a plug board in it, so you can see here each of those lines come into a line here. Hang on, let me zoom in a bit. And there is a little box full of patch cables, and you can patch. You can do null modems, and I'll go into that in a minute. Null modems or straight through, and you can make sure that the control signals are on the right pins and they go to the right. One control signal goes to the the data carrier detector in the other side, or whatever. So. And there's some ground pins on either side that you can ground particular signals to. But this was a little and on the outside it gives you what all of those 25 pins under the relevant standard, the EIA CCIT modem terminal interface standards, and what goes to what, and whether it's data terminal equipment or datacom equipment. So is it incoming or outgoing? So yeah, interesting little box. Now, but wait, there's more. There was more boxes pulled out from underneath the underneath this particular drawer. This is again a black box. Now this is a slightly more sophisticated version. Again, they are dual sex connectors on both sides, but it comes into a it gives you all of LEDs on all 25 of those titles of those pins. It shows you whether they're open, there's continuity, or there's a short. And you can step through each of these, or you can scan through. You can automatically scan through each of these, or you can step through manually. There's a 9-volt battery which goes in the pocket here. Again, there is a little key to give you for your 25 connectors, your 25 pins. But this was a slightly more upmarket cable tester. You could plug in your null modem, and you could actually see the swap over here. You could see the swap over the control signals, etc. If it was a true null modem cable that swapped all of the control signals as well. So now this was I suspect quite an expensive piece of kit in its day from the Black Box Company. But wait, there's more. We go to a much more expensive looking case here. That's the cables. If we go around here. Now, this was a Tristate tester for RS-232. I suspect this was quite expensive in its day. What it enabled you to do is these are actually little pins, and you could put patch cables from one side to another, or you could connect them directly. These are dual inline switches. You could automatically do your null modem, which 2 to 2 or 2 to 3, so transmit data to receive data, etc. You could automatically do null modem. You could then put clear to send high, data set ready high, and data carrier detect high. So those three control signals, you could actually say they're latched up high, so allow the data through, and the data set's ready, etc., etc. So you could make up your own little mini null modem cable here. You could connect these together, or do a straight through by the dual switches. On the key control signals and the transmit and receive data, there were LEDs, there were Tristate LEDs in here, as well as there was an LCD screen. Now, I haven't put batteries in this because it takes 3 9-volt batteries. But you could then put the meter on. It was giving you voltage, it was giving you all sorts of things on the way through. So it was testing whether it was RS-232 was plus and minus 15 volts. So your RS-232 transceivers needed to be able to take plus and minus 15 volts because you if you had long cable runs, you were transitioning plus and minus 15 volts, so 30 volts across 30 volts to get the signal through the other end. But yeah, this is and in the other side, in this side are all of your control cables. This is the you've got dual sex cables out each side that come out, and you connect up to your particular piece of equipment or your particular cable that you want to test. So and I suspect this was quite expensive, well and truly. Of course, yes, of course it was expensive. Everything at Black Box sold was expensive, but quite nice nonetheless. I love it, Sean. You're spot on. Black Box was always good. You could always guarantee the thing, the piece of equipment would work. But yeah, you also paid the price on it being a pretty expensive device at the time. So, but anyway, I rescued these. RS-232, you're making me feel old. Bronson, yes. Well, yeah, I have just confirmed my old farts status because when I got into computing, this was what it was all about, and you were connecting terminals to terminal node controllers and terminal controllers, and you were going through and doing the RS-232 to RJ12 and RJ45 cables and all sorts of stuff. Now, I just thought I'd show you. I built this a very long time ago. Now, this is definitely old fart stuff. This was my RS-232 tester. Now, I know it looks a bit Heath Robinson, but there is both sides. This is the data terminal side. If we zoom in here, it's labelled data terminal equipment, so DTE. So this has the receive and transmit data on the right pins, and then there is data comms equipment, so DCE on this side. There are some TX and RX LEDs on here that give me both states in both directions. If I made this very impressive null modem, so you could actually go click with 2 of them. I needed 2 of them to do the switching. Was in null modem, so it crossed over the cables, and then it was through on this one, and it puts it all the way through. And I've used this. I have actually used this particular piece of equipment quite often, and you'll see it's a bit horrific in the back, but anyway, it works. It definitely works. It gives me the ability on both sides. Again, there is dual sex on both sides, both DB9 and DB15. And I've got some adapters on there and bits and pieces that I use. But anyway, that was my. I could never afford the black box price tag, so I built my own. So yeah, that's what you do when you can't afford equipment, but you've got lots in your junk box. You come up with your own little test jigs. Anyway, okay, Hey, yes, Andrew, yeah. Especially when most UART's bodging these days is RX-TX ground if you're being fancy with both directions. Spot on, Andrew. Well and truly. What are handshaking signals? Why do you need handshaking signals? I've worked on a televideo 912 serial terminal sitting on the shelf behind me. Well, Sean, I have a couple of. I'll admit I've got a couple of them. VT100 terminals, actual real VT100 terminals. It used to be on an ICL that I used to look after, ICL mini computer that I used to look after. So there you go. It was running the ICL version of Unix, which whatever it was a weird Minix, I think it was. Anyway. Oh, there you go. So that's enough reminiscing for now. We'll all fall asleep in a minute if we don't watch out. Now, space weather report, just finish off. There is a HF fade out warning that is been issued by the Bureau of Meteorology Space Weather Forecasting Service. Now, the 17th, we're at the 17th. There is an R0 or R1 chance of R2 possible. If comms difficulties experienced, then try a higher frequency band. So there you go. So that's the HF fade-off warning. Now, May the 1st, which is our next presentation night, I'm giving a talk on Pop Medhurst, who was A7AH, or XFM. XFM was before the Paris conference in 1925 started allocating call sign prefixes to countries. So XFM was Pop's call sign when he was using Spark. He's a bit of a legend, definite legend to wireless in Tasmania. So I'm giving a bit of a talk on him on the 1st of May. Jim Palfreyman I've mentioned. There is a special something on the July the 3rd, and I'm not going to give that away. And on August the 6th, we have My Life in the Lighthouse service by Mike Jenner, VK7FB, who spent time in, I think, 4 of the lighthouses around Tasmania, and is giving us a bit of a talk on his time. And I understand there is lots of pictures and even some videos that Mike has dug out. Now that's in August the 7th, and then on September the 4th we've got an amateur radio quiz night organised. So that's all the way through to September. So there you go. Oh, definitely, Sean. No, they were about to be turfed into the e-waste bin, and so I put myself at mortal risk between them being thrown into the e-waste bin and the e-waste bin, and I caught them and they disappeared very quickly. So I didn't quite dumpster dive, but I got very close to it. I put my life in mortal danger. So now, very last thing, this is fascinating. If I put this on here, you will notice that it is a Yaesu. It's a very nice Yaesu MH-36 DTMF microphone. This is a bit of a dead giveaway because it's an 8-pin DIN, 8-pin DIN, not a RJ45. But you'll notice there is absolutely no plastic on any of the curly cord. The plastic on here disintegrated off the curly cord, and progressively, as I was using it, more and more of it came off, and to the point where there was absolutely no plastic on the curly cord. Now the plastic, there was obviously something wrong when they they put the formulation together for the rubber, but anyway, I need to change it over to one that's in slightly better condition than that. It does work perfectly all right. It does tend to get tangled in quite a few things, but anyway, the plastic rubber absolutely disintegrated off the whole lot. I had little bits of plastic in the shack forever. Anyway, oh, Andrew, yes, a bit of a nightmare, but anyway, all right. 73. We're at 8:30. Hope you got something from tonight, and we'll have another program next week with equally interesting things, I hope. So we'll catch you next time. Keep an eye on the Discord channel, and we'll see you next time. This has been VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our Wednesday Experimenters Group Night, the WEGs, and we'll catch you next time. 73.